All right, so I'm going to go over the remainder of the geometry OST practice problems in this video. So questions 22 through 30. We left off and finished 21 during our last geometry meeting. If you haven't seen or watched the video of me going over problems 7 through 15, make sure you do that. But yeah, let's finish this up. So question 22 gives a map of Jane's town with her home and workplace shown. Jane wants to determine the shortest route from her home to her workplace, and she can only walk on the sidewalks that have the dotted lines on the map. So we want to calculate the distance of this shortest route to the nearest whole block. And we can only use the dotted lines. So I'm sure we've heard of the saying that the quickest way or the shortest distance between 2 points is a straight line. So instead of going like corner, like go to the left and go to the right, why not go diagonal, go left or up? So we want to try to essentially go as direct as possible, using as many diagonals as possible and limiting kind of our extra movements. So if we start at home, we obviously can take a diagonal pretty quickly to this center square. Now, unfortunately, we do have to go around this square, and then we can take another diagonal, and then we just need to go straight down to get to the workplace. So that should be the quickest route because it does use those diagonals. So each of the blocks, or each square, is worth 1 block. So for the ones that are straight vertical and horizontal, we can count. So we have a 3, we have a 1, and then that's it. So now we have to calculate the diagonal lengths, which we can just use Pythagorean theorem because we can construct a right triangle, find the side lengths, the legs of that right triangle, and use the Pythagorean theorem to find the missing side. So I'll call this missing length x and then the top one y. All right, so Pythagorean theorem for x, I can do 2 squared plus 3 squared is equal to x squared. So that's 4 plus 9, 13, square root of 13 as that distance. Now we don't want to round to the very end, so I'm going to leave that as square root of 13. And then to find the distance y, we use the legs 6 and 3. 6 squared and 3 squared, 36 plus 9 is 45. And so y is the square root of 45. Okay, so we want to add up all those distances. So we know we have the 3, the 1, and the 1 from the straight up and down or left and right movements, and then plus square root of 13 and square root of 45 for the 2 diagonal movements. When we type this into our calculator, we'll get about 15.31. We want the nearest whole block, aka the nearest whole number. So that's going to go down to 15. And that is how we do problem 22. All right, question 23. An equation is shown where x is between 0 and 90 and y is between 0 and 90. And we know that cosine of x degrees is equal to sine of y degrees. And we want to be able to create an expression for x in terms of y. How are x and y related? Well, there is an an important relationship between cosine of an angle and sine of an angle, specifically when they're equal. So cosine of some angle x is equal to sine of another angle y if x and y are complementary. We did learn that this year. So if x and y add up to 90 degrees, then cosine of one angle will always be equal to sine of the other. So x plus y must equal 90. X and y have to be complementary. So x is equal to 90 minus y. And there is our expression for x in terms of y. Question 24 is a probability. So we are given two events, A and B, and they are independent. We are given the probability of A. We are given the probability of A and B occurring together, and we want to find the probability of B. Now, when we have two events that are independent, and we did a problem like this way at the beginning, the probability of two independent events occurring together will always be the product of the individual probabilities. So because we know the events are independent, the probability of A and B occurring is the probability of A times the probability of B. So all we need to do is substitute in the probabilities that we are given, and we can easily solve for the probability of B by just dividing 0.3 out, and we will get that the probability of B is 0.8. 0.8 times 0.3 does indeed give us 0.24. All right, question 25 is another data question, probability question. So we have a total of 200 people attending a party, and some of the numbers, like the total male, female, the total adults and children, and then the grand total is shown in the table. A person is selected at random to win a prize. The probability of selecting a female is 0.6. And here's why that makes sense, right? If we look at how many females there are, 120 out of 200 total. If you divide 120 by 200, we will get 0.6. So that doesn't help us with anything. We already know how many females there are. Now, the next thing we are given is that the probability of selecting a child, given that we know the person is female, is 0.25. Okay? So we know there are 120 females. And it says if we know we have a female, then 0.25 of them are children. So 0.25 times the 120 females, we will get 30 children who are female. So I'll put that in our table. And then once we know that, we can really easily find the remainder of these missing blanks, right? So for total females, we can do 120 total females minus 30 children that are females. And so there must be 90 female adults. And then you can also do that to help with your males, right? It's because every time you add across, you should get the total at the end. And every time you add down, you should get the total at the bottom. So that forces, if there are 150 total adults, 90 of which are female, then there must be 60 male adults. And if there are 50 total children, 30 of which are female, then 20 must be male, and then that works across as well. But in case we didn't recognize that and we used the next piece of information, here's how that would work. So the probability of selecting a male, given that we know the person is a child, is 0.4. So if I know we have a child that's being picked, there are 50 children, and of those 50 children, we have a 0.4 chance of getting a male. So 0.4 times 50 will give us 20, which we can already verify up above that we have that filled in. So really, we just needed one of those probabilities, and then we could fill out the rest of the table just using addition and subtraction. Okay, question 26, another probability independent event. Okay, so Sam is picking fruit from a basket that contains many different kinds of fruit. And we want to know which event is independent, which set. So remember, independent events mean that one event has no effect on the other. So if we look through this list, A says Sam picks a kiwi and eats it for event 1, and event 2, he picks an apple and eats it. Well, you might think, well, he picks a kiwi for the first event, so that shouldn't matter. That shouldn't affect my second event. Well, he eats the kiwi. So now he doesn't have as many fruits in his basket when he picks the apple second. Okay? For B, same thing. In his first event, he eats the apple. So when he picks out his next event, there's not as much fruit in the basket. So that first event really did have an effect. C, again, event 1 involves Sam eating the first fruit he picks out. So he has less fruit to pick from on the second event. Which forces D, the only option in which the first event, he gets a kiwi, but he puts it back. So then when he picks again, he still has the same amount he is picking from. Those are truly independent events. Okay, question 27. The probability of flipping a fair coin and landing heads facing up is 0.5. The probability of rolling a fair number cube with sides numbered 1 through 6 and an odd number landing face up is 0.5. What is the probability of flipping heads or rolling an odd number? So doing one or the other. Okay, so let's write down some information. We know the probability of flipping heads is 0.5, and the probability of getting an odd number is 0.5. And we want to find the probability of getting a heads when we flip the coin or getting an odd number when we roll the die. So this is an either or scenario. So there is a formula for this, which states that the probability of either or occurring is the probability of one occurring plus the probability of the other occurring minus the probability that they both occur. right? So if we didn't do the minus both, we would have 0.5 plus 0.5. So you're saying there's 100% chance you get an odd number and heads is landing up? No, obviously you could get tails and then you could get a 2. There's not 100% chance that either of those will happen. And because when we count all the different ways you can get heads or all the different ways you could get an odd number, sometimes there's an overlap, right? Sometimes there are scenarios where both will occur and we're already counting them individually. So we need to subtract the times that they occur together so that we're not double counting anything. Okay, so this is a pretty important formula in probability. Now, we know the probability of each individually, but how do we find the probability of both? Okay, since these events are independent and they are not, it's not told that they're independent, but what you flip on a coin has no impact on how the die roll will go, right? Because it's two different things. So we're going to use what we already used in this video. When we have two events that are independent, the probability of both occurring at the same time is their product. Okay. So then we're going to do some replacement. So probability of heads occurring is 0.5 plus probability of an odd number occurring is 0.5 minus the probability of both occurring is their product. So minus 0.5 times 0.5. So that gives us a 1 minus 0.25, which is 0.75. So there's a 75% chance that when you do these two events, you'll either get a heads or an odd number. Okay, and we need it to be less than 1. So it being exactly 1 didn't make sense. We knew we just couldn't straight up add the two probabilities. We had to subtract the probability that both occur at the same time. All right, question 28. A translation is applied to triangle PQR to create triangle P prime, Q prime, R prime. And we want to write a rule. What are we doing to X and Y? So let's compare two of our points and make sure we're starting at one of the points without the prime and going to the point with the prime. So like from R to R prime. So to get from R to R prime, we have to go up 3 and left 4. And now we just have to remember our translation rule, right? Anything that we are doing left or right would affect our X coordinate. Now, A represents the X coordinate. So that means we take our starting X coordinate and we subtract 4 to get our new X coordinate. And then B represents the new Y coordinate. So to get the new, Y coordinate, we take the old Y coordinate and add 3 to get the upward motion of 3. So remembering that translations involve addition or subtraction within your points. All right, question 29. This is a flow chart proof. We haven't seen these, so let's try our best to figure out what's happening. So we have a triangle and an incomplete proof that are shown. We are given in this triangle that angle B is congruent to angle C, and AD is an altitude of triangle ABC. And we want to prove that this triangle is isosceles. So I'm just going to draw a larger image of this triangle. And then we are given that B and C are congruent. So essentially what happens in a flowchart is they start with the two congruent statements and kind of go down from each, or they start with the two given statements, excuse me, and then see what we can get from each. Okay, so one of the first given statements is that AD is an altitude of triangle ABC. Okay, and then from that they said, okay, well then the two angles at the bottom that are formed must be 90 degrees because that's the definition of an altitude. Okay, that makes sense. So from there, what else do we need to get to? Because what's happening is we're going from the 90-degree angles, saying that they are congruent, and then somehow we are also saying that these two inner triangles are also congruent. So their end goal is to prove that the two smaller triangles are congruent. We already have a pair of congruent angles in B and C. We have a pair of congruent angles now that we know that they are both 90 degrees. So then what else can we use to prove that these triangles are congruent? Well, we know if we look at the two triangles that they share a side, and that side is AD. And if we look at our answer bank, there is a statement that says AD is congruent to AD. And we know that the reason any segment or any angle is congruent to itself is because of the reflexive property. Okay, so let's look back at what we have. We have a pair of congruent angles in B and C. We have a pair of congruent angles at the point D, and we have a pair of congruent sides. And if we look how those are arranged within our triangle, we have two angles next to each other and a non-included side. So that is a triangle congruence that we learned. We can say that those two triangles are congruent through angle, angle, side, triangle congruence, which is a reason that we can use from the bank. Okay, so now we now have two congruent triangles. So then if we move to the right, it jumps to, well then AC must be congruent to AB. Well, why can we claim that? Because we have congruent triangles, we can now use CP/CTC. That now any corresponding parts of those congruent triangles are also congruent. And then it finishes up saying, well, now that I know that those two sides are congruent, the entire outer triangle must be isosceles by definition. I think the most difficult one to get is this one, and kind of figuring out where it goes. So if you try to kind of work through this proof on your own, you would probably end up realizing you have to make this claim. You have to show that AD is congruent to AD. And it's just a matter of, okay, I need to place that somewhere. It's also helpful that they have that bank down below, so you can kind of think about what's available to you as far as statements and reasons go. Okay, last question. We have circle M and N that are shown. And we want to complete the statement to explain how it can be shown that two circles are similar. So circle M can be mapped onto circle N. So what that is saying is we're making M turn into N. Okay? Now, if we look, it starts with a reflection. So I just look at the two centers, the center of M and the center of N. The center of M is up 5, and the center of N is down 5. So it's a perfect reflection across the x-axis to get those centers to match up, right? So that should be pretty easy to recognize. So the centers are aligned, but now we need the scale factor, right? So that's where it's key that we know we're starting with M and we're turning it into N. Because remember, to find scale factor, we always want to do the new shape divided by the old shape. So that would be N divided by M. And what can we divide out? Well, we can just quickly check their radii. So N has a radius of 3. M has a radius of 2. So 3 divided by 2 would be our scale factor. And I'm not sure if it's given as 3 over 2 or 1.5. I think it's 1.5. And that's a good thing that our scale factor is bigger than 1, right? Because we know to get from M to N, there has to be an enlargement. M is getting larger to map to N, so our scale factor better reflect an enlargement. And it does because it is greater than 1. Okay, and that's all of the problems. I definitely recommend looking through the entirety of these problems, really probably studying and absorbing the probability, since we definitely didn't talk about probability at all this year. Remembering some of the formulas and characteristics that I talked about. And there were a lot of probability questions on here, so it's definitely something I recommend reviewing before our test. And thanks for